Hi, everybody. Glad you're watching today. Let's keep going through chapter 2. Today we're on for 2.4, solving polynomial equations in factored form. I actually really like this lesson. I get super excited about it. So if I get carried away in my excitement during the video, please forgive me. Okay, so number one, let's review what factors are. We want to write the number 240 in factored form. So kind of try and remember back to your middle school days here. I think you did this, it was probably like 6th or 7th grade. But if we take 240 and we want to write it in factored form, we want to break it up into its different factors. 240 has a lot of factors. So if I start breaking it up, I know 240 can be divided into 24 times 10. The 24 can be divided up into a few different things. 8 times 3 is one of them. And the 8 can keep going. Oh, and I stopped here with like the 3 because it's a prime number. So you can't keep going with the branches there. 2 is a prime number, so I'll stop that one there. 4 can keep going into 2 and 2. And then this 10 over here, the only way it can break up is 5 and 2. Both of those are prime numbers. So in factored form, the number 240 would be 2 times 2 times 2 times 3 times 5 times 2. You take all of the bottoms of the branches. And you can check on a calculator to make sure that really does equal 240. So, just like numbers can be written in standard form or factored form, polynomials are the same way. We can write them in factored form or in standard form. So the factored form of a polynomial would be right here, and the same polynomial just in standard form would be over here. And we know how to get from factored form over to standard form. It was just our last lesson. So here we'd distribute the 2x, and we'd get 2x squared plus 6x. Here we learned the FOIL method. We'd do all of our foiling, and then we'd eventually get x squared plus 2x minus 8. So we know how to go from factored form to standard form. Now, for in the future, what we're kind of going to focus on is going from standard form and how do we break that up into factored form. So just like we broke 240 up, we want to take these polynomials and break them up into their factors. That's like a big part of this year in math is factoring. So before we get to factoring though, a couple other important things. Number 3, there's a pretty handy rule that helps us solve equations that are in factored form. It's called the zero product property. Here it is if you want to pause the video and copy this down. It says if the product of 2 or more factors equals 0, at least one of those factors must equal 0. So like I said, pause the video if you need to get that down on your notes. So if I think of 2 numbers and their product equals 0, this rule tells me that at least one of those things must be 0. So today in class I said, shout out a couple of numbers that when you multiply them together, their product is 0. So kids shouted out like, I think somebody shouted out 10 and 0. Well, is at least one of those factors 0? Yeah, that second one is. And so I said, keep shouting things out. And so somebody said something like 0 times 0 equals 0. Well, is at least one of these factors 0? Yeah, they both are here. And, you know, somebody got fancy and they said, well, what about something like 500 times 0? Well, and the rule still holds true because at least one of those factors still is 0. And nobody could think of a couple things that when you multiply them together, if they equal 0, at least one of these things always had to be 0. Nobody could think of an example where one of them wasn't 0. So the zero product property works with regular numbers. It also works with polynomials. So over on number 4, this zero product property is pretty dang awesome because it helps us solve equations that you didn't know how to solve before. So like up until now, you could never solve this equation because there were a couple of different x's and you didn't know how to deal with that. But now that we have the zero product property, it kind of expands your math world and you can solve these different equations that you couldn't before. Somebody in class was funny. They were like, but I don't want my math world expanded. Well, it's good to expand your world. So the zero product property says that if I have a couple of different factors, like I do here, I have one factor, two factors. When I multiply those together, if it equals 0, at least one of these factors has to equal 0. So either x equals 0 or 2x minus 4 equals 0. The x equals 0, that's already solved. The 2x minus 4 equals 0, we can continue solving that. Just use our good old algebra properties. So I'm going to add 4 to each side, and we get that 2x equals 4. And then I'm going to divide both sides by 2, so we get x equals 2. Occasionally you've seen this, but from here on out, a lot of the equations that we've solved will have 2 or even more answers. Most of the equations you've been dealing with so far in your life usually have one answer. X just equals one thing. But these polynomial equations will have more than one answer. You don't have to do this on your notes, but over the years, if you ever wanted to check your solutions, you always took the solutions and you plugged them into the original equation. So over to the side here, I'm just going to do that. First, I'll check the 0. So I'll plug in the 0 for all of the x's, and hopefully it really does equal 0 in the end. So 2 times 0 is 0, minus 4 is negative 4. So the whole thing in the parentheses turns into negative 4. 0 times negative 4 really is 0. So that one checks out just fine. Now we need to check this 2. So I'll plug a 2 in for the x's in the original equation. Do the stuff inside the parentheses first. 2 times 2 is 4, minus 4 is 0. And what do you know? 2 times 0 really does equal 0. So both of these solutions really do check out. They are good solutions. Let's practice a couple more. Example 2, I've got 3x plus 6, 2x minus 3. So using the zero product property, we know that either, oh goodness, having a hard time talking and writing at the same time. We know that either the first factor, the 3x plus 6 equals 0, or the second factor, the 2x minus 3 equals 0. When we solve these down, I'm guessing a lot of you can just do this in your head. So we'll subtract 6 from both sides, and then we'll divide both sides by 3. Looks like x is going to equal negative 2 in the end. On this one, we'll add 3 to both sides, and then we'll divide by 2. So x will equal 3/2, or 1.5 if you like decimals better. So we have our two solutions for x. If you want to, if you're ever not 100% confident that you did it right, feel free, plug in the answers, check them, just like I did on example 1. I'm not going to require that you do it, but it's always an option for you. Okay, example 3. I tried to get a little fancier here. We've got 3x and 3x plus 12 all squared equals 0. Remember, 3x plus 12 squared really equals 3x plus 12 times another 3x plus 12. Luckily for us, the zero product property works with more than 2 factors. It works with as many factors as you've got. So I've got 3 factors here. The zero product property tells us that at least one of those has got to equal 0. And I know it seems a little repetitive, but I'm actually going to write the 3x plus 12 equals 0 out twice. On this first factor, to solve for x, I divide both sides by 3. X is still going to equal 0. On this second one, I would subtract the 12 and then divide by 3. So x is going to equal negative 4. And we know this third one is going to be the same. So there are actually 3 answers for x there, even though 2 of them were kind of repeating each other. Boy, the more factors you have, the more solutions you're going to have for x. Once a couple years ago, somebody said they wanted a challenging problem that had to do with this. So I wrote a big equation out that was already in factored form. It had like 12 different factors. So there were actually like 12 different solutions for x. But the zero product property will work for as many factors as you've got. Okay, so to finish out 5 and 6 here. What if a polynomial is in standard form, but we would really like it to be in factored form? Well, the process is called factoring. I think I've already said that word a few times during the video, and that's basically what the whole rest of this chapter is about. So today we'll learn one type of factoring where we look for the greatest common factor, or GCF. Let's practice. So here is a polynomial in standard form. I would really love for that to be in factored form. In fact, the instructions tell me to factor it. Finding the greatest common factor is basically like the distributive property in reverse. And I know you're all great at the distributive property, but what we're going to do is we're going to find the greatest common factor. I'll leave a blank line for the moment. And we're actually going to pull it out front. So instead of distributing something in, we're going to pull this greatest common factor out front. And then we're going to write what's left over in the parentheses. So between 5 and 30, the greatest common factor, the biggest thing that I can divide out of both of those is a 5. And out of z squared and z, the biggest thing that I can divide out of those is a z. Wouldn't be z squared because I can't take 2 z's out of this one because there's only 1 z to take. So my greatest common factor is 5z. And I'm going to kind of do, like I said, the distributive property only in reverse. We're pulling that out from both of the terms. When I divide that out, all I'm going to have left is z plus 6. So I basically divided each of those original terms by the greatest common factor. That is now in factored form. So we have factored it, and you should be pretty proud of yourself because you just factored your first polynomial. You'll do many, many, many more this year. Okay, let's try a couple more. Second one, 16a to the 4th plus 4a. As I look through those two terms, the biggest number I can take out of 16 and 4 is 4. Whoops, whoops, whoops. Still writing in boxes here. So 4, and then a to the fourth and a. The most a's that I can divide out is just 1. That's all this one has. Now, what's left over after I pull or divide that greatest common factor out front? Well, let's see. 16 divided by 4 is 4. I had 4 a's. I pulled one of them out, so there's 3 left. Over here, 4 divided by 4 is 1. I had 1a, I pulled it out, so there's no more a's left right there. So we factor that, pulling out that greatest common factor. Just kind of similar here, 30b to the third plus 40b squared. And actually, I wouldn't mind if you paused the video and tried this one on your own, and then unpaused it and see how you did. So between 30 and 40, the greatest common factor, the biggest thing that I can divide each of those by is 10. Here I've got a b to the third, I've got a b squared. The greatest amount of b's I can pull out is 2. What's left over? Well, 30 divided by 10 is 3. I had 3 b's, I pulled 2 of them out, so I've got 1 left. Plus 40 divided by 10 is 4. I had 2 b's, I pulled both of them out, so there are no b's left there. Not spaced very well, but that is factored. Just for kicks, I made one with really large numbers in it. (5,000x to the 179th power plus 7,000x to the 200th power. That might be the biggest polynomial you've ever seen so far. 5,000 and 7,000. The biggest number I could divide each of those by evenly is 1,000, I believe. And the biggest amount of x's I could take out is 179 from each one. What's going to be left over? Well, it'll be, let's see, 5, because 5,000 divided by 1,000 is 5. I had 179 x's. I pulled all of them out, so no more x's for that term. This one's going to be 7x to the, what is that, 21st? I had 200 x's, I pulled 179 out, so there's 21 left over. Hopefully that's enough examples that you feel comfortable pulling out a greatest common factor. Now, number 6, last but not least, let's pull everything together, and we're actually going to pull out the greatest common factor and then use that to help us solve the equation. So notice these actually have equals 0 on the end, where these ones in number 5 did not have equals anything in there. So now we're actually solving for x. 3x squared minus x equals 0. I think the only thing I can pull out of there is an x. What's left over? Well, it would be 3x minus 1. Now I can solve this because I have it in factored form, and I can now use the zero product property that we were talking about a few minutes ago. So I take each one of those factors, set them equal to 0. So x equals 0. This one would be 1/3, it looks like. Before today, you could never solve something like this, but now that we know about factoring and that zero product property, you have totally expanded your math world. Solve for x. I made a typo here. There are no x's to solve for. These are c's. Okay, greatest common factor, whoops. 10 and 2. The biggest number I can divide those by is 2, and then I can pull a c out. So I'll have 5 plus c left over when I pull out the greatest common factor of 2c. Now that it's factored, I can use the zero product property to set each one equal to 0. first factor, I divide both of them by 2, so c equals 0. Second factor, I'm going to minus that 5 over, so we'll have c could also equal -5. There are your two answers. And like I said, if you want to, you can always check those answers and make sure they really do make that equation equal 0. Last but not least, sorry, this video's gone a little long. Once again, I typoed. I think I was copying and pasting a lot, and I forgot to change the variables. 3n squared equals 9n. This equation is different than anything else we've seen today because it doesn't equal 0. Well, when you get something that doesn't equal 0, you better make it equal 0 so we can factor it and solve it. So I'm going to subtract 9n from each side. Now this will work out better because we made it equal 0. Pulling out a greatest common factor, it looks like I can take out a 3 and an n. So I'll have n minus 3 left over. We set both of those equal to 0. And I know a lot of you can do these steps in your head. On the notes, I'll still write out kind of every little step though. So n is going to equal 0, or n could also equal 3. Those are your two answers. Thanks a lot, guys, for going through this, watching this with me, and kind of expanding your math world today. See you back in class soon. Thanks a lot.